students, welcome back to chemistry class. In the previous class, we have discussed different zones, the flames, okay, and finally we have concluded with how to calculate calorific value. So how will you differentiate fuels on the basis of calorific value, okay, which is most ideal fuel? Such kind of things we have discussed in the previous class. Okay, and today we will move on to the next topic. So we have learned this many things in the previous class. Moreover that today we are going to learn the next point. So how an ideal fuel become? What is an ideal fuel? What is an ideal fuel? You know the types of fuels, okay, whether it is inflammable or whether it is undergo combustion very fast, or whether it get explosion, or those kind of things we have discussed so far. And now we are moving on to the ideal fuel. How a fuel become ideal? You know, students, in the classroom there will be an ideal student. That student will be, yes, model for all other students. He may be good in studying, he may be good in in performance in art, he may be good in dancing, so many activities he may be good. That same way, how a fuel become ideal? Ideal fuel have some characteristics. Okay, if it possesses those characteristics in a correct way, you can select that fuel as a ideal fuel. So, what are the characteristics of ideal fuel? Characteristics of ideal fuel. How an ideal fuel should be. Okay, so in the previous class we have discussed calorific value, right? So the calorific value of an ideal fuel should be more. Okay, so the first point, it should have big calorific value. Big calorific value. Big calorific value means it should produce large amount of energy after combustion. Okay, so any other characteristics? Yes, if a fuel wants to become ideal, it should be cheaper. It should be cheaper. Cheaper means if a fuel possesses 1 liter, like petrol and diesel, you know that 1 liter, now it's showing 82 rupees for 1 liter. So if the rate is increases as much as, so the normal people cannot buy it possibly, right? So the availability also will be rare. So that time we will depend some other fuels which is not having that much calorific value. So it should be cheaper also. It should be cheaper also. And any other point? Yes. An ideal fuel should be easy to transport. Easy to transport from one place to another. If it is highly inflammable or it is highly dangerous means it is not possible to carry out. Carry through oceans and all. So it should be easy to transport. An ideal fuel should be it should be easy to transport. And the next point what we are going to discuss is it should not produce poisonous substances. Should not produce poisonous substances means, so after combustion or while transporting, it never produces any poisonous substances. Once it produces any poisonous substance means it will be adversely affect to you and your surroundings. Okay, so coming to this point, the next point can be right. It should be, an ideal fuel should be eco-friendly. An ideal fuel should be eco-friendly means what? So after combustion, it should not produce any poisonous substance that we discussed. But it should be eco-friendly means any other residue should not be left over after combustion. If anything left over poisonously or dangerously, it will be adversely affect to your environment as well as your body. Right? Yes, so it should be always eco-friendly. There may not be any residual part after combustion, should not be left over after combustion. That point also we have to come into our mind that when we talk about the ideal fuel. So at last we can discuss the sixth point. We can discuss that, yes, we all have discussed ignition temperature, right? Yes, that point also you have to consider here when we talk about an ideal fuel. So how is the ignition temperature of that particular fuel? Will it be high? So we all are keeping this fuel in a room temperature, right? We all are keeping this fuel in a room temperature. Just imagine that the ignition temperature of this particular fuel, if it's more than, if it is less than those room temperature, means it will catch fire, it will be hazardous, right? So it should not happen. The ignition temperature of the particular fuel will be less than that of the normal room temperature. So that point is very, very important. If a fuel become ideal, means its ignition temperature should be, its ignition temperature should be more than that of room temperature. That of room temperature. If it's less than room temperature, means it will catch fire, or it will be it causes for explosion. So in the atmospheric in the presence of atmospheric oxygen or in the normal temperature, sometimes it will catch fire or sometimes it will explode it. Okay, that will be dangerous. So to try to avoid that, you should always take care that ignition temperature should be more than that of room temperature. Okay, if it comes below room temperature, means it will be adversely affect to your adversely affect to the environment, as well as it cause explosion and all. Okay, and this many points you have to remember when we talk about the ideal fuel. If the fuel possesses these all characteristics in a right way, you can consider as this fuel is the best example of a ideal fuel. This fuel can be considered as an ideal fuel. So this is how hydrogen is the most, hydrogen is the ideal fuel for those other fuels, because that possesses those kind of characteristics nicely, and you can consider it as a best example of an ideal fuel. Okay, so I hope you remember this point. In your textbook there is a table. So in that table, that different calorific value, the fuel efficiency has been noted over there. So you can check it over there. Okay, so out of this, by looking at the calorific values of different fuels, or by looking at the uses of different fuels, you can consider as which one is the best fuel, which one is the ideal fuel. Okay. Okay, students, after discussing those ideal fuels, now let's move on to a problem. This problem is there in your textbook. This question, in an experiment, 4.5 kilogram of a fuel was completely burned. Okay, the heat produced was measured to be 1,80,000 kilojoule. Okay, and your task, calculate the calorific value of the fuel. Calculate the calorific value of the fuel. So whatever is there, which is there in the question. So look at here, 4.5 kg of a fuel is completely burned. So after that it produces energy, right? So thus heat produced was measured to be how much? 1,80,000 kilojoule. Calculate the calorific value of the fuel. So how will you calculate the calorific value of the fuel? So as we know that calorific value of the fuel is equal to, how will you calculate? You know that calorific value of the fuel is equal to heat produced divided by heat absorbed. Heat absorbed. So children, how much heat is produced? You know that 1,80,000 kilojoule heat is produced, and the heat absorbed is how much? It is heat absorbed by how much gram of fuel? It is 4.5 kilogram. 4.5 kilogram. So how much? Finally, the answer become 40,000. Yes, 40,000 kilojoule per kilogram. Okay, this is the calorific value of the particular fuel, because 4.5 kilogram of fuel was when it completely burned. Okay, this much amount of heat is produced. So when they calculate it, so finally we will get 40,000 kilojoule per kilogram of fuel. I think by looking at the value, this is a good fuel. Okay, the calorific value is comparatively big. Okay, this problem you have to copy it in your notebook. Okay, thank you.